Hi everybody on YouTube. Today we're going to be talking about thermoelectric coolers, or TEC modules, or pelter junctions, or whatever you want to call them. I was interested this summer in power generation. Commercially, these little guys are usually used for heat pumps. The fascinating part comes to life is when you keep one side hot and one side cold, you get just the reverse. You generate electricity. This is where I became interested because up here in North Dakota, if you say have the outside of the house, it could be 15 below zero. In our wood fireplace inside, well, if you could find a nice spot that stays under the melting point of the solder inside the junctions, well, you know, 250 degrees, that's a hell of a temperature difference. So I immediately bought a dozen of these things and some giant heat sinks, and I had myself a little hot plate here to simulate the wood stove. And I found that if I take one of these little modules, I think it's a 55 watt, that particular one, put it on top of my little hot plate, anywhere from 200 to 250 degrees, use this little aluminum heat sink, a smaller piece of aluminum for height difference, and you simply put the globe from a kerosene lantern on top to do the chimney effect, that you can generate enough voltage and current to actually run one of these little portable wind-up radios that run for almost nothing through the sun or to wind them up. Alright, this is our standard laboratory hot plate set somewhere in the 250 degree range. Little aluminum spacer there, and wedged in between is the thermoelectric cooler module, and on top is a little heat sink from my little Coleman portable fridge, and this is the globe to a standard kerosene house lamp. That's just doing the chimney effect, replacing the fan for a passive cooler like this. And currently we're generating about 3 volts stable, pretty much. Well, I'll have to see that later. And here is my little wind-up radio. I have this wired directly from the TEC to the probes right to the radio, and that's going into the winder generator part. I figured due to varying voltages and test, this will be the most reliable as in not burning out the radio and the circuitry. But this little operation, just with that TEC, this little heater and a passive cooling, giving us a 3 volt and slowly declining voltage, I figured, well, hey, you can use that on a stove or anything that has a temperature differential, and especially in the wintertime up here in North Dakota, you can have a very large temperature differential from the minus whatever it is outside to as hot as we want to keep it on the inside here. Alright, this summer when I was really into this, I had the money to burn. I bought one dozen, maybe it was 10, I think it was 10 of those tech coolers, or maybe it's 12, I don't know, it's probably 12. 12 of those on eBay. And I run across these badass heat sinks, and I just had to buy 2 of them. Spending way too much on those, but anyways, probably about the coolest thing I've got hanging out here. I don't know. Compared to this this little thing and that little thing, it holds its own. Anyways, we got the I think there's 8 tech coolers sandwiched in between the hot plate and the heat sink. Currently running the radio, generating 2.7 volts and climbing on a modest temperature, only a 3 on the dial. So each cooler puts ours at like a volt and a half, and I figured, well, if we could stack like a dozen of these on top of each other and get up like 16 volts, and have one side on my wood stove and one side facing the outside of the house to the winter weather, and if you ran that through maybe a $20 charge controller off eBay, real simple 10 amp something or other, you could in turn charge the battery bank up. And I figured, well, hey, if you can generate 3, 4, 5 amps at the most, if you stack these things, you can stack them right on top of each other, and the heat just goes through each one of them, and that's where you get your juice, as long as you have the temperature differential on each side. But if you stack these, that'd be like having a solar panel going 24 hours a day, 7 days a week, because we always keep our wood stove going because that's our primary heat source in the wintertime. But it was a thought, but I ran out of money to buy more coolers. I did burn one up in a test. That didn't go so well. So I got to keep them in a reasonable temperature. Well, we're running at 2.9 volts, sitting on 2.5 on the little heater there. I don't have a. I want to get an infrared temperature gun, or one of those laser temperature guns, so I can actually see temperature differentials and calculate those. Running my little radio just fine. It'll sit there and do that. It's not even warm, and I've been doing this for like a half hour. You can sit there and run that all day long on just a small temperature differential. Alright, when I say stove, I mean our Jensen forced air wood stove that's ducked into the household ductwork. Forced air, usually get an air temperature somewhere between 120 and 200 degrees. And I figured, well, a guy could probably duct that and make a fixture on the window where we bring our wood in. And one side would be outside and one would be on the inside, and that would vary with the air temperature coming out of the stove and the air temperature outside.